Welcome to Study Loop.
This is the answer to Chapter 22, problem number 28 from the Smith Organic Chemistry textbook. And this problem is asking us to draw the polymer Kadel that would be created from the combination of these two monomeric subunits. So 1,4-dihydroxymethyl cyclohexane on the left here, and terephthalic acid, which is this para dicarboxylic acid molecule here on the right. And so the polymer that we would create from the combination of these two is a polyester. So remember, a carboxylic acid and an alcohol are going to come together to form an ester. And so that's what we see here. Each monomer of the polymer is joined to the monomer next to it by an ester linkage, and it will just alternate one to the other, then back to the first one, then to the second one. And so that's what I've drawn here. I've drawn just two subunits of this polymer. Obviously, it could extend pretty much indefinitely in either direction. And then we're asked to explain why this is a stiff polymer. It's used to make clothing that's crease resistant and somewhat difficult to fold. And the answer is that the polymer backbone here contains rings. It contains a lot of rings, both cyclohexanes and aromatic rings, aromatic six-membered rings. And so rings constrain movement. So remember, these carbons are sort of locked into place because this is a ring. So there's not there can be rotation along this carbon-carbon bond, but not really along this carbon-carbon bond or this carbon-carbon bond. And that's because, again, it's part of a ring. And even more so in this aromatic ring system. And so the rings sort of lock some of these carbons into pretty set conformations. And because the molecules are not as free to move around, the polymer strand as a whole is less free to move around. And we see that loss of freedom of movement on a macroscopic scale as inflexibility and resistance to creasing. And so that is the answer to Chapter 22, problem number 20.